Good morning. Yeah, I'm Eric Kiltie. I'm the UK Engineering Manager with UniversalPegasus International here in Aberdeen. And I'm going to present to you today some the status of some study work that we've been doing for OGTC. And it's a study specifically to examine some of the challenges and opportunities associated with the reuse of subsea equipment. I've got quite a short time here, and I'm also trying to pitch it for a mixed audience. So if I've missed anything out or MD requires some more detail, we've got a presence in the Balmoral suite. So a couple of my colleagues will always be there, so please do come along and ask us, or just give us a shout. We'd be delighted to meet up with you later on. I've actually got a personal interest in the reuse of subsea equipment that dates back to the mid-90s when I worked for LASMO. And I worked on the decommissioning the Staffa field, and when we decommissioned the field and done all the seabed clearance trials, I put a huge amount of energy into trying to market the equipment that we had recovered, and I was entirely unsuccessful. And I found this quite heartbreaking at the time. But then again, if you wind the clock forward a few years, when I was a project manager for a greenfield development, my first job as a project manager, I was actually offered some reconditioned equipment to use, and it declined. And it declined because the risk and the reward just didn't stack up for me. And there's a bit of a conflict there, obviously, and maybe perhaps a bit of hypocrisy, but I think I was wrong, and I think I was right on both occasions. So this study, I think, is being quite good for me, because this has troubled me over the years. So this gives me the opportunity to exercise some demons and understand why that gap exists between recovery and reuse. In the North Sea, it turns out that there's actually very, very few precedents for the reuse of subsea equipment. And most of them that do exist are limited to fields that haven't met production expectations and have faced early decommissioning. In other words, the equipment was still quite young when it was recovered, and so had quite a high degree of confidence. It's an interesting observation that was made by one of my colleagues that reuse of subsea equipment post-recovery seems to be shrouded in misgivings. Everybody's got perceived risks, etc. Yet our company UPI, we're regularly asked to perform life extension studies for equipment that's remaining in place. So maybe just try and keep that in mind as we go through the presentation. So I'll run you through some of the methodology of the study that we've been doing for OGTC. The first step we took was to look at 2 North Sea fields that are currently awaiting decommissioning, and the purpose of this was to try and understand some of the key risks and challenges that would surround reuse of equipment that actually wasn't designed to be reused. We've spoken to some manufacturers and service companies to try and solicit some input to gauge their feelings, to see what the support might be. And then we've proposed, in collaboration with Crondal and Exodus, what a reusable development might look like. So a standard kit of parts that I think both Gordon and Steve have talked about earlier. We've performed a cost estimate based on that one-hit single use. And then we've applied some of the learnings that we've taken from looking at the real case of some decommissioned equipment. So we've been able to add in some costs for recovery from refurbishment, redeployment, and the mitigation of some of the principal risks that we see. That is based on a program of 4 consecutive developments. So the kit of parts is being used 4 times in series. And I think that 4 number in the program, it makes sense to me because a lot of the data that we've been getting on the small pools, the design life or the production life is typically going to be of the order of 5 years. 4 times 5 is 20, and a 20-year design life is something that we understand, we're comfortable with in the North Sea. And then finally, we've tried to capture some of the key areas that we might have to change in terms of design and mindset in order to bring reuse forward and make it a reality. So I'll just talk a wee bit about some of the two fields that we looked at to try and understand some of the challenges and risks. And these were the Osprey and Merlin fields, which have been operated by Fairfield Energy, but both are now currently being prepared for decommissioning. And what that meant was that we had access from Fairfield. Fairfield gives a lot of support with us. We had access to some real data in terms of the design of the equipment and also its service history, as much as was available. Both were installed in the 90s, Osprey very early 90s and Merlin in the mid-90s. So some of the equipment really did have very, very limited design life or operational life remaining, although I must say that it was still fully certified while in production. But COP has been called on these two fields, and they're currently being prepared for decommissioning. And because they're quite elderly, and because they were never designed for reuse, I think we've got to accept that they were never going to be viable candidates for a reuse case. But being able to study them closely has been valuable exercise, and certainly in trying to understand some of the risks. So this layout's probably quite familiar. Gordon and Steve have both alluded to it. It's what we think collaboratively that a tieback of the feature is probably going to look like. And we've defined it together. And I think it's consistent, as Gordon says, with trends that we've seen in subsea tieback developments in recent years, and it's also quite consistent with a lot of the data that we've received on what some of these small pools might look like. So what is it? It's 10-inch production pipeline, 6-inch gas lift pipeline, rigid or perhaps some of the composite pipe that Steve talked about, some form of reusable control system, as Gordon went through. 2 wells with an off-tree flow management package, so taking all the metering, the gauging, and the measurement off the trees to simplify the trees, and a gravity-based manifold. So we've got to be clear here that one of the key concepts here is that there's no protection from fishing interaction. And this is, as Graham talked about earlier, this is a huge departure from what you're used to. But it's very, very key to being able to reuse this equipment to enable us to recover straightforward and also redeploy. And the basis of this as well is that it's full decommissioning, everything's removed and a clear seabed is left. So there's no decommissioning in situ, and I think that, and minimal disturbance to the seabed, and that's also key to the whole concept. Now, at this point, I think it's worthwhile to talk a wee bit about just what's involved in taking equipment ashore and refurbishing it, because it is, I think you need to understand that this is quite a challenging endeavour. This is not a case of taking equipment onshore, giving it a steam clean on the quayside and then sending it back offshore. Requires a lot of planning and precaution, requires licensed sites, and requires waste management plans and strategies. And deviating from those plans really does expose a company to some serious reputation risk. I think we're all familiar with some of the stories that have been reported in the press in the last few months. Dealing with norms, naturally occurring radioactive material, or LSA scale you might be more familiar with. Dealing with norm contamination, in my experience, is quite straightforward if you acknowledge it, if you recognise it as a risk. The mitigation measures are well understood, and you don't have to expose people to those occupational hazards. Although saying that, dealing with having to decontaminate some larger equipment, or certainly longer pipelines, if you like, brings its own difficulties, like dealing with large volumes of wash water. There's, without a doubt, in my mind, there's a gap in the current onshore infrastructure to deal with a lot of equipment coming back onshore. The licensed sites do exist, and the licensed contractors, experienced contractors do exist, and I think we're all familiar with them. But there's a bottleneck in the UK. There's a bottleneck in the UK due to the higher level of decommissioning activity right now. So if we were to get serious about using kit over and over again, I think that we will either have to see some kind of investment in an offshore infrastructure, or indeed move towards not bringing equipment ashore at all, or certainly minimising that. Lastly, just thinking about refurbishing conventional equipment, and this connects back with some of my experience of LASMO and also being a project manager in a greenfield development. Refurbishing conventional equipment brings with it its own set of pitfalls and its own set of risks. And I would never, as a project manager, I would never have reused equipment on my critical path in a project. You cannot put all of your project eggs in that one basket without a credible backup plan, or having equipment that's specifically designed to be reused. So based on some of the data and knowledge we had of the Osprey and Merlin equipment, were performed a risk analysis. Now, this was a risk analysis performed on equipment that's not designed for reuse, such that we could understand some of the risks that we could then move forward with either mitigating or designing out. And this was quite a lengthy exercise. In fact, it's not quite complete yet, but I've just like to outline maybe some of the top 6 that we've identified, just to give you a flavour. So number 1 is inaccurate or insufficient data. Data on the design of equipment, data on how it was installed, data on how it was maintained, changed throughout its life, and indeed operated. Without a full set of accurate data, you're forced into making assumptions. Erosion, corrosion, and coating damage speak for themselves. However, saying that coating damage was mostly noted as a risk during recovery of rigid flow lines. Polymer aging is a recognised issue with umbilicals and flexibles. They're fine when they remain in a static condition, but once we start recovering them, bending them, stretching them, this can cause damage to certainly to some of the polymer components. Conditions beyond design or exposure to conditions beyond the design boundaries, the boundaries that the equipment was designed for. Pressure, temperature, we all know that things happen. They seem to happen in the night shift a lot, where equipment's perhaps used slightly beyond the envelope it was designed for. Uncertainty over contents. I'm specifically thinking about what you're going to find when you break a connection, what's inside a pipe or a vessel. Manufacturer support is the last one, and some of the obsolescence issues. If we're talking about a 4 development program with a common set of parts, if I'm buying that set of parts for development number 1, I want to know that when I get to development number 4, the manufacturer is still going to be able to supply me with spares and consumables. But the big conclusion I draw from this is that there's no showstoppers. I'm not seeing anything here. I'm not seeing. We've not identified anything in the frightening bottom right-hand corner of that Boston matrix. So I see that all of these risks can be overcome or designed out. So we've done a wee cost exercise. Still work in progress. But if you remember back to the typical tieback of the future scheme that I described earlier, We've costed that based on a one-hit development, so a one-use, and that's represented by the blue bars on this graph. And then we've rerun the costs for 4 consecutive developments with ultimate decommissioning and disposal of equipment after development number 4. Now, this is a standard component set, so this assumes that none of the major components are going to be replaced between developments. And it also assumes that the equipment is actually designed to be reused 4 times. We've added in a nominal allowance for refurbishment of some of the components in between developments, but none of the major components are taken ashore, and I think that that's an important assumption here. But the indication here is that we think that using a set of parts 4 times offers a 33% saving in CapEx average over the 4 developments. And that's a significant prize by any measure. That actually really, when I was presented with the spreadsheets the first time, I asked the guys to go back and have another look at it. But I've checked it myself, and this really does, really is presenting itself as a serious opportunity. So, going back to some of the technical issues and some of the bits and pieces that we've uncovered from looking at real cases, just like to talk a wee while about some ideas and what we've come up with about how we would do different things differently moving forward. There's some fairly obvious low-hanging fruit, like never being uncertain over the integrity of lifting equipment like pad eyes. We think that there's room for standardization and interchangeability. That would certainly be important if perhaps we were running 2 or 3 of these multi-development programs in parallel. We would want to know that we could swap kit in between the programs. I think we have to be really, really open-minded when it comes to new technology, particularly some of the controls, the reusable controls equipment that Gordon described, some of the pipe coatings that Steve spoke about. The days of this is the way we've always done it are long gone. That is not acceptable anymore. We need to be looking forward now. Data acquisition. This is really a bit of a personal hobby horse for me. I personally think that we need to be recording and measuring everything that we can. Pressure, temperature, strain, acoustic, ambient conditions. We need to be recording everything, and we need to be keeping that data in the cloud, such that we can do with it what we want sometime in the future, but we need to know it's there. And we need to recognise that the technology is ready. It's ready for this. It's been developed for the military, and I think it's easily transferable into oil and gas. And I think that some of that data, or all of that data, should certainly be available to the manufacturers, if not managed by the manufacturers, such that they can preside on the integrity of equipment as it goes through design life, and indeed look to improve their own designs. And lastly, we need a shift in mindset, both at the project stage and the operations stage. So it may be a different project team between development number 1 and the others. Well, the project team in development number 1, it's not acceptable for them to be thinking about their own development. They need to be considering the life of the kit through the 4. And equally, the guys in the control room of the host facilities need to adopt a mindset where they're respecting the integrity of the equipment, they're respecting the design parameters, they're keeping chemicals available. So, second last slide, I'd just like to talk about some of the gaps and uncertainties that we've uncovered here. So, gaps and uncertainties in terms of what we've found, but also some of the assumptions that we've had to make to progress our study. The first one is I think that we really need a bit more work in terms of an overarching design basis for this tie back to the future. We've developed some fundamentals that we all collectively feel comfortable with, but I think that we could quite realistically develop a detailed design basis that would maybe cover 80% of the small pools that have been identified as prospects. We've seen that the risk level varies between components, and that's quite easy to understand. Something that's quite agricultural, like a piece of pipe, it lends itself to be used a number of times. But some of the more complex equipment, like trees, does attract a higher risk profile. And I think that we would need to work on trying to smooth that risk profile out to gain confidence in the whole concept of reuse. Support and buy-in from manufacturers, I talked about a wee bit earlier, and I think that we know who they are, we know who the key players are, and I think that we need to understand just how they're going to support this moving forward. Larger operators stuck in their ways, I don't know about that, but they've certainly got strict standards and specifications, and there may be a challenge pushing them outside of those. Commercial hurdles, Steve's talked about earlier, but I see there being a challenge with transfer and acceptance of equipment. Certainly if there's a different partner group between these four developments, there are going to be issues with who has responsibility for refurbishment, and also what the next partner group has to do in terms of inspection and acceptance of equipment. One obvious way around that would be to have a detached party looking after the equipment, perhaps through some lease arrangement. I talked about the onshore infrastructure and the lack of, and I think that probably the easiest way to tackle that is to look at minimising or completely excluding the need to take equipment onshore. And lastly, compatibility with host facilities. I think you talked about it earlier a wee bit, Graham. All subsea tiebacks are going to attract some capex in terms of topside modifications, and that varies quite a lot. We've assumed a uniform capex for topside mods, but I think we've got to recognise that that's going to vary depending on the age of the facility and how some of the process equipment is set up to deal with a new set of fluids. So what are my conclusions here? Well, my number one conclusion is that this is reuse of a subsea set of parts is a realistic objective. It's a valid aspiration, and I don't think we should be scared of it. We're not seeing any roadblocks. We're not seeing any roadblockers. It requires a different way of thinking, but you can tell by the vibe round about the industry that people are prepared now. They're prepared to move forward and look at things differently. I've talked about recording data and service parameters. It's manageable and it's doable. Onshore handling needs to be minimised or excluded. But finally, let's not lose sight of the fact there's a big prize available here, and there's nothing stopping us from getting after it. And that's all I've got to say.